You are watching the Algebra Alcove with your host, Mr. Pemberton. Episode 3, Systems of Equations, Elimination Method. In this third method to solve a system of equations, we will take a look at the elimination method, which involves eliminating one of the variables and solving for the remaining variable. Notice in this system of equations, the x's, positive x and negative x, are of opposite signs from each other. If we wanted to add these two equations together, notice the x's would cancel each other out and would have nothing left. This is called elimination. One of our rules for elimination is that we can add any two equations together. In this case, because the x's cancel each other out, leaving no x's left, the 2y take away 8y can be combined together as a negative 6y. The 1 and the 17 can be combined together as 18. Notice what we have left is a simple one-step equation. By dividing both sides by negative 6, we end up with the result that y has to be negative 3. So now that we know one of our variables, we need to determine what the other one is. So since y is negative 3, we can go back to one of the two original equations and choose one of these equations to substitute our previous answer into. So we are going to take negative 3, and I'm going to choose the top equation because it has smaller numbers, less likely to make mistakes with no negative signs. And so I have taken the x plus 2y equals 1 equation, and I am going to replace y with negative 3. That now makes this equation x plus 2 times negative 3 is equal to 1. If I solve this equation, 2 times negative 3 is negative 6, giving us x minus 6 is equal to 1. And now the one-step equation, by adding 6 to both sides, gives me a result that x is equal to 7. And therefore, my solution to this system of equations, x is 7, y is negative 3. This is the point where the two lines would intersect each other had we chose to graph them. For this next problem, I have the system of equations negative 3x minus 2y equals negative 19, and 9x minus 8y equals negative 13. Notice in this system of equations, the x's and the y's, if you were to combine them together right now, cannot cancel each other out. In order to eliminate one of the two variables, we need to choose which variable to eliminate and then try to make them equal to each other, but having one with the opposite sign. For example, here we have negative 3x and a positive 9x. It would really be nice had this been a negative 9x, because if this were negative 9x combined with 9x, the x's would cancel each other out. So we are going to make this a negative 9. In order to do that, we have to multiply everything in the equation by positive 3, because positive 3 times negative 3 would turn this into a negative 9. However, we must remember to distribute the 3 by everything, everything, everything. And therefore, the 3 times negative 3x makes negative 9x. The 3 times negative 2y makes negative 6y. The 3 times negative 19 makes negative 57. So this top equation has now been rewritten in a form such that the x is now a negative 9x, and now notice the x's are now ready to cancel each other out. we can now combine these two equations together. The second equation I did not have to do anything to, and so I recopied it, and now we're going to eliminate the x's by combining these together. 9x and negative 9x cancel. 6y and a negative 8y combine to make negative 14y. Negative 57 and negative 13 combine together to make negative 70. This one-step equation can be solved by dividing both sides by negative 14, and therefore negative 70 divided by negative 14 gives you a positive 5 for the y. Now that we know what y is equal to, we can go back to the original problem and figure out what x is. My original problem had these two equations. I could choose either one of them to substitute y is equal to 5. I could plug in the 5 here, or I could plug in the 5 here and work it out to solve for x. I am going to choose the bottom equation. It doesn't matter which one you pick. I chose the bottom equation. And so when I solved this equation, since I know that y is equal to 5, by substituting 5 in for the y, this now becomes 9x take away 8 times 5 is equal to negative 13. The negative 8 times 5 is negative 40, leaving us with a two-step equation. 9x take away 40 is equal to negative 13. By adding 40 to both sides, that cancels the 40 out, leaving 9x on this side. Negative 13 and positive 40 combine together to make 27. Dividing both sides by 9, we find that x is going to have a value of 3. And therefore, our solution to this system of equations, x is 3, the y value is 5, giving us an answer of 3, 5, the point at which the two lines would intersect each other had we graphed these. In this final problem, if you notice, the x's and the y's are not so easily canceled out in this problem. Not only that, but it's difficult to multiply one equation by something in order to get the x's or y's to cancel without resorting to fractions or decimals. In this scenario, there are times where we may need to multiply both equations by some number in order to make either the x's or the y's cancel each other out. For a problem like this, we want to think of the lowest common denominator. I can choose to eliminate either the x's or the y's. In this case, I decided to choose the y's. If you notice, the 3y and 2y, if we wanted to know what's the lowest common denominator of 3 and 2, you would say 6, because both 3 and 2 can divide into 6. What we are wanting to do is, in our equation, we would like this to become a 6y and this to become a negative 6y, so that the y's would cancel each other out. And so that is what we are going to do. If you'll notice, I decided to multiply the top equation times 2 in order to turn this into a 6y. I chose to multiply the bottom equation by negative 3 because negative 3 times 2y will become negative 6y. And then the 6y and negative 6y would be able to cancel each other out. So the result of those multiplications, 2 must multiply by everything, making negative 8x, positive 6y equals 32 by multiplying 2 times negative 4 times 3 and times 16. The negative 3 gets multiplied by everything. Negative 3 times negative 3 is 9x. Negative 3 times 2 is negative 6y. Negative 3 times 10 is negative 30. Notice now my two equations look like the very first example we saw, where one of the variables is already set up to eliminate. So by combining the two equations together, negative 8x and positive 9x will make 1x. The y's eliminate each other. 32 take away 30 is 2. So we are left with 1x equals 2, which at this point you know the answer is x equals 2. The formality of it, by dividing both sides by 1, we see that x is 2. And now that we know the value of x, we can take this answer and plug it into one of my two original equations. So my original equations, I could choose the top one or the bottom one. I chose the bottom one. And so now that I know that x has a value of 2, by substituting 2 for x, I can now solve this equation by going negative 3 times 2 is negative 6, plus the 2y is equal to 10. We now have a two-step equation. We're going to add 6 to both sides, creating 2y is equal to 16. 10 plus 6 is 16. Negative 6 and 6 cancel. And then by dividing both sides by 2, we discover y is equal to 8. And now have our solution. X has a value of 2. Y has a value of 8. As a coordinate, they intersect at 2, 8. Had we graphed our two equations, this is the point at which the two lines would intersect each other. You have been watching the Algebra Alcove with your host, Mr. Pemberton. Episode 3, Systems of Equations, Elimination Method. In this video, we saw how to eliminate a variable when both equations are already set up to cancel. On an occasion where we only needed to multiply one equation by a constant in order to make one of the variables eliminate each other. And we saw a third example where we occasionally will multiply both equations by some number to create a lowest common denominator in order for one of the variables to cancel. Thank you for watching this video.